Can someone else try speaking?
Yeah, hear you loud and clear.
Yeah, we hear you.
Okay. I was getting a little worried. Oh no, echo.
You're fine.
Okay, is the echo continuing? All right, awesome. No echo now. I'm just waiting for my co-chair to join in. I saw him in an earlier session. And while we're waiting for Tail to join, is somebody willing to act as our scribe? We don't need like line for line. This is being recorded, so we don't need like the narrative and the whole dialogue captured. What we really need is any decisions that get made or sort of resolutions we come to captured, please. So hopefully it's easier. A scribe. Well, really the scribe for the hedgehog doc, the hedge doc. So I guess no take or scribe, you change whatever you want to call it, but really we need resolutions captured and not the whole back and forth. We're not looking for a court reporter.
And I confirm, as the AD for this group, we need to get a scribe taking the minutes before starting.
I can take the notes.
Thank you. And make sure you add your name into the Ether doc so that we can see who gets the credit for the awesome scribing. So thank you. Is Tail on yet? I do not see Tail. Short co-chair. Okay, so let's get started. We have a fairly good agenda, and Tail will join when he can. So we have the scribe selection, and I think we're good to go then. So I've uploaded one of the big changes with this version of Meet Echo is that we now have the slides directly being pulled in. So I've preloaded the slides, so when it's a presenter's turn to speak, you can actually drive the slides directly out of the session yourself without having to rely upon one of the chairs to push the buttons for you. So hopefully this will work nicely. I've preloaded them all, so hopefully we're all good to go. So we're going to spend a couple minutes focusing on NoteWell. We've been asked by the ISG to spend a little bit more time than we normally do on NoteWell. Obviously, this meeting is an IETF activity, and it is covered by NoteWell. But in particular, there is a request every working group has had to apply a little additional focus around making people aware of the conduct and the behavior. Not that we're calling out and saying that anybody in ADD has been causing a problem. We've all been getting along very, very well, in my opinion. So this is more of a reminder to all of us, and not in any form a slap on anybody's wrist. But please be aware that we are all working here together. Be kind to one another. The IETF does have anti-harassment policies in place. We have an ombudsman to work with, and if you just take an extra second, if you're heated and impassioned in the discussion, take the extra second to have an extra breath before you maybe respond harshly or unkindly to somebody's point that they've made, and we'll all get along very well. And historically, ADD has got along very, very well. It's been one of my pleasures to co-chair this group because, in fact, we are so well behaved. I'm Glenn Dean, obviously. I'm one of the co-chairs of ADD, and Tail, aka David Lawrence, is my co-chair. Mr. Eric Vink, and I don't think I'm saying Eric's last name perfectly properly because I don't have the proper accent. But he's our lovely area director, and he gives our good oversight and overview and management of the ADD working group. So here's our agenda for today. We are going through that. We've done the note well. We've done the admin portion. This is the part where we have the agenda bash. If people looked at the agenda last night, there was one change overnight in that we had an additional topic here, which was the SVCD draft. There just wasn't a lot of new material for there, so we don't have any slides being presented on that. So we pulled it off the agenda. So that gives us back actually a few more minutes for extended discussion on the other topics today. Anybody in the chat? Anybody or want to speak up? Any changes to the agenda that people want to propose at this point? Okay, I'll assume that that agenda bash is completed. So the very first topic we're going to do is DDR. And who is going to present talk for DDR? I see Tommy Polly popping up. Hello, Tommy. Good morning. And Tommy, okay, so I don't know in this new interface, how do I give you control?
I'm going to ask to share slides.
Okay, well, your slides are already uploaded. So if you...
No, I pressed the button to request to share them.
Oh.
And then I can click through them.
Oh, okay. Grant.
Yep. Let's see.
Did you get it?
I've not gotten the permission yet.
Well, I clicked on the yes.
One first.
You may want to stop yours first. Yeah.
I stopped mine.
Okay, and I'll re-request. There we go.
Awesome.
All right, can you see this? Perfect.
We can.
All right.
So,
I'm-
Tom, you have 15 minutes overall for the sort of to lay out the stuff. We've allocated 20 minutes to talk about the extended topic at the end, so Q&A. So you have a lot of time, so we enjoy.
All right, sounds good. Hopefully we can converge on this. All right, so I'm Tommy Polly presenting on behalf of our other authors for the discovery of designated resolvers. This is one of our adopted working group drafts. So first, just to update people on the status, we did have a draft 03 that was published in October. The main updates there were to align with the newly adopted DNS SVCB draft that Ben put out. And then it also added some text to explain that we have these documented methods of validating or verifying resolvers using certificates or just using the fact that an address is shared. But clients may use other methods that could be more strict and more relaxed in the future. This opens up the possibility for things like Ben's other draft about how to handle forwarders. So it's not required that implementations support that, but they can, and this kind of gives implementations the freedom going forward to choose different methods, and that these are just kind of the two base methods. Another change I'd like to point out that was an editorial one that we made just recently was to change the name of one of these modes from the authenticated mode to the verified mode. Martin Thompson pointed out, and was correct, that when we are checking to see that an IP address is covered by the certificate of the DO or DOT server that we're connecting to, it's not really a true authentication because we just, we had this IP address that was just, someone typed it into their machine or we got it over DHCP. That really what we're doing is we're just verifying that the things match up. So rather than wading into the notion of what is authenticated or not, we're just going to say it's verified. Other than that, that part of the protocol does not change at all. So that leaves us with one currently open issue with one pull request that I have made to satisfy that. So I want to go into detail now on the contents of this pull request. And there are a couple different changes in it, and so I want to walk through these different ones. And as I go through these, I want to make sure that we kind of all understand it and that if we have any clarifying questions or concerns about each point, that we can sort those out now. All right. So the first change in here, which I think is kind of like the main core change, is something we've discussed before. I think it's ultimately not going to be really controversial. It's just what is actually being verified. Previously, the text for the case where you already knew a name, like I knew I'm talking to dns.google, I just have to check that that thing that I already knew was covered in the certificate. That was clear. In the case in which we already knew only the address, like I only knew 8.8.8.8, we said you have to check the address and the name in the certificate. Martin rightly pointed out that that really isn't consistent. There's no true need for the verification to actually check that other value, and it adds a lot of complexity. So the change here is to simply say, hey, if you discovered, if what you started out with and what you issued your DDR query for was based on a known IP address, you should check and verify that that IP address is covered in the certificate. If you discovered based on a known host name, you check that host name in the certificate. And those two cases are just what they are. No other checks that you do within the certificate for verification for the purposes of DDR. So are there any questions or objections to this point here? I see in the chat, Martin says it's sensible. Great. All right. I think that goes forward then. All right. Next step.
Sorry. We have a person in the queue.
I don't see someone in queue. Okay.
It popped up.
That's fine.
And then it went away. Did somebody want to comment back on?
No, Vinny.
Okay, Vinny, go ahead.
Clarify, when you say IP address, it's both the resolver IP and that you own the IP that was originally used to bootstrap the discovery, right? It's both of those.
Yeah, specifically this is if the thing I had received over DHCP or had manually configured was 8.8.8.8, and I issued a UDP port 53 query for the SVCB record of dns.resolver.opera to quad 8, then when I actually connect to the Doer server, I look for quad 8 being in that, because the thing I started with was quad 8.
Right. Okay. Okay.
Becker?
Well, so now I'm confused. So I thought I understood. So I think we all agree that the thing you started with better be the certificate. I think the question is does the thing that you got as a result of the DDR have to be in the certificate? So I start with quad 8. I get, hey, look over here at, I don't know, quad 4, and then just quad 4 to be in the certificate as well.
So right, it used to say yes, and now it just says you just check the thing you started with.
Okay, that's what I thought you had said, and then I got confused when you were talking to Vinny. So
sorry, yeah.
No, I'm not listening close enough. So while it is a little yucky to not have the I think the way to think about this is a CNAME, effectively, right? And so the rules for the CNAME are the thing you start with, the thing you look up, not the thing you end up with. Awesome.
Yep. All right. So this is the core thing. I think we all agree on this, and that is a big win. Woo! There are a couple other changes. The first one here I also think is very non-controversial. We need to clarify that you didn't start with resolver.opera. You must not use that within the SNI or your DO request authority. That is not a thing. So just really laying that out. I think that's a good thing. If for some reason you disagree with that, please speak up. And then the last thing, which I think needs most discussion here, is while the thing you check is the address or the name that you started with, there can be this intermediate target name. So, in the case I gave before, we have quad 8, but there also is this identity of the thing I'm connecting to, which may be a DO server that is running on as dns.google or something like that. And should I be allowed to, as the client, use something other than that original IP address, quad 8, as the authority, as the name, there's the host I'm connecting to in the DO URI. Martin's in queue. I do have an example that I want to walk through here, just to go through. Is that okay, Martin, if I quickly bounce through that? Hello.
Yes, go ahead. Sorry, I got cut off.
No worries. Yeah, so in general, like, we could do it either way, but the place that I think it's ugly if we say you must only ever use that original address is this. So let's say I start out with quad 8. I receive the following answer for it. I see, oh, this is dns.google. It has a DO server running H2. Great, I'm going to use that. Along with that, because this is SVCB, I will either have received IP address hints, but I'll have to either have additional records that came along with this for A and quad A, or I'll issue specific queries for A and quad A of dns.google. And so that resolves me to quad 8, 8.8.4.4, and I have some IPv6 addresses. Our client stack prefers that we use IPv6 addresses. And so now, I'm connecting to an IPv6 address that I know is for dns.google. That's the thing I resolved. I'm going to check quad 8 in the certificate, but is the client allowed, because it knows that this is dns.google, to put that as the authority, or must it put quad 8 as the authority even when it's talking to an address that is not that? And just for example, like our implementation stacks of HTTP, it's often awkward and not even publicly accessible API to have a different host than the thing that you're doing the actual DNS A and quad A queries for. And that's the case we have here. And so, Martin, please chime in.
We should be looking for whatever names might appear in the DNS for these things. I think we should start with what we have and end up with the same thing. So there are a couple of places where you're going to be using this information. Mm-hmm. If you're doing O, there's obviously two places, SNI and the host header field.
Yep.
And I think the SNI field is a simple one. Don't put it in because you you have been configured with or have discovered an IP address, and you don't put IP addresses in that field for some reason. The host header field, I think the same applies there. You've got an IP address, and that's what you started with, and that's what you put there as well. All of the intermediate stuff that you might have discovered along the way is information that is internal to the resolution process that you have. And so while it might be nice that you have some nice names along that path, I don't think that there's something we want to put into the protocol.
Okay, so two questions here. So one, you did mention kind of like the thing that we did DNS for. When we talk about doing DNS, the thing that I issue an A and quad A record for, query for, is dns.google. It is not quad 8.
Correct, but you started with an IP address, and ultimately
which
you're
never
going to
showed
be
up in a DNS query, right? I was asking for resolver.arpa.
Right, but you are you not authenticating against that IP address when you make these queries? You're not, are you? Or
I'm just verifying that IP address is covered in the certificate. I'm not authenticating against it.
Right, but you're okay. So that's the key question, which is when you feed this information into your stack is going to say is going to receive a string, and that string is going to contain an IP address, and stacks don't want to have one thing going into that and another thing going into the host header field or the SNI field. You're gonna,
Right.
you're
And so
gonna
it's
do,
very common for us, and it, like, I know several, public APIs that allow you to customize your certificate validation and verification,
yes,
but do not let you separate out, here is the name that gets resolved into addresses from the host. And so essentially all I'm saying is, like, it should be allowed for the client to use that DNS.Google name instead of Quad 8, but it could use either.
yeah, I think that just complicates things unnecessarily, and that customization is not possible in a whole lot of stacks. You might have that flexibility, but that's not a common case.
Okay. All right. Let's hear from other people. Ecker?
So I think I basically agree with Martin, but I actually have a less philosophical and perhaps more practical concern. Imagine the illustration in which you have name-based virtual hosting, and in which you get one thing if you stuff in 8888 as the host header, and you get another thing if you stuff in safe lookup.google.com. Right?
Yep.
And so the consequence of this design would be to permit the on-path attacker in the network to force you into a different resolution you otherwise would have gotten, which would not have been possible in the setting where the thing that was stuffed in to the host header was the thing that was configured. And
okay.
So I thought about it for a little bit, and maybe you could persuade me that already is a problem, but I don't think it is. And the reason is because maybe there's no actual configuration this way, but it seems to me you could have a configuration that was this way. And because the point is, it's not merely a matter of validating the certificate; it's a matter of what the client tells the server what its expectations are. And the server may or may not use SNI for this purpose, and the host header is what's intended for this purpose. And so if you key only on the host header, which would be legal in this case, then you would get different responses. And so I think that this introduces a vulnerability which they shouldn't do.
So I think this is something that already exists, because you also have the DOE path, which could also be a way of splitting up. Like, I could have a different path for different functionality. I could have, safe DNS query and this DNS query. And we could also imagine extensions to the SVCB format for resolvers that includes other parameters which say, oh, this is the one that does our, malware filtering, and here's the one that doesn't. Like, I mean, we could imagine that there could be a validity around having different options. And, to that end, I think the only thing we really are confirming is that Quad 8 is covered in the certificate. All of the other aspects, if someone is attacking me to try to get me to go to a different variant of that server, they already could by changing the path. And that means that, essentially it's a feature of this that you could have different things. And now we're essentially saying, if you have different services offered by something that can be delegated by Quad 8, they can only use the path, and they cannot use the name to offer those different services. And I think that's an unnecessary restriction. So, you could certainly have a client that only says, I'm going to use the address I got. But saying that, it is illegal for the client to use that authority, even if it knows a meaning behind it and knows that it's safe to do it, I think that's going too far.
Well, now you're persuading me to do it, but it's bad. I mean, seriously. I think that basically I think that, like, the underlying security property we're going for here is that the thing that was entered in, the thing that's configured, is determinative of the responses you get, and that's all this nonsense about, like, equivalence was supposed to mean. And so like, if we're going to have anything that is not covered by that, then the text needs to say, then the text of the specification needs to forbid differential behavior based on anything that can be configured by the attacker. And so, that would mean dope path, and it would mean dope path, and it would mean in this case host if we were allowed that. So I think like I'm happy to file a separate issue, but I'm just saying like that it's not a reasonable it's not a reasonable setting to have the situation be that that there's a way for the attacker to completely change the response by material that is not authenticated. And that's what I mean. It was like a very long time to convince ourselves that couldn't happen, right? And so like so I think that like that's actually a real problem. But I also think that like the dope path situation is actually slightly less serious in the sense that at least the dope path is under the same authority, whereas in the situation I'm discussing, things are completely different authorities. And so imagine for instance, I guess so. Here's my hypothetical: Cloudflare.
Yep.
Cloudflare serves on the same, I don't know if they do, but they serve on the same IP addresses. They serve Cloudflare Do, and they serve like they serve like Eckers like lying Do resolver, right? And the situation in the situation with Do path, it's not possible for the attack. If Cloudflare only has one DNS path, right, then there's not possible for the attacker to force the wrong answers. But in the situation with I'm allowed to specify the host, then in fact I can just divert them entirely to my resolver and my fake resolver, and I can say anything I want. So it's actually much worse. As long as Cloudflare shares certificates for that IP address and it doesn't have to show them for the domain. Right? So,
they would have to allow that IP address to show up on the certificate for this other name.
Well, but right. But I mean that does not. Well, no, it doesn't have to show up in their name. Right. All it has to have is it has to allow you to connect to 1.1.1.1 and feed in a host header that was an ordinary host header, and that would be sufficient.
Right. So you're saying after the TLS validation, then it just redirects it off to something else.
Well, I mean, it just steers based on just a host, and that's not right. Which I mean, bear in mind is a permitted behavior because it's generally permitted behavior because of connection pooling. So anyway, I guess I think this is more fun. But I'm happy to write this up. But I think this is more fun. Yeah. But I do want to specify. I have no idea what Cloudflare actually does, so I just use Cloudflare as an example because I know the CDN that multi-host. So like people can tell me they don't do that, but that's not my concern. Is not that Cloudflare in particular than anything.
Okay, that makes sense. So I guess if we go this route of saying you have to have it, then I guess the question is, are people okay with sending the authority of Quad 8 to an IP address that's a v6 address? And if we're fine with that, then we're fine with that.
Yeah, I think so.
Okay. Right.
I'm still not clear on what the exploit is there.
Who's talking?
Maybe I'm just not like the Cloudflare.
Vinny, did you want to get in?
I could write it up if that would be helpful.
Hi, Ben Schwartz. So another way to interpret what Eric was talking about is that allowing this client behavior implicitly imposes a bunch of hidden restrictions on the server. Servers, in order for this to be safe for the client to do, servers have to avoid a bunch of configurations. There are a bunch of configurations where that would become insecure if the client is allowed to do this, and there are also configurations that would stop working. So one of those is one of the things that I thought was fun here is this. I think implicitly requires that both the IP address and the target name appear in the same certificate. First of all, it requires that the server have a certificate that covers the target name.
Does it?
Well, so we can step back and say, is the client actually going to verify that this authority is present in any certificate, that the host is authoritative for this authority?
I think it's only verifying the address.
Okay, so in that case, then you're doing something very exciting. You have an HTTPS connection with an authority that is completely unverified. And while that might sort of be safe in this particular case, in general, it's extremely unsafe. And it would allow...
Which is why originally it said you checked both.
Right. because it would allow things like allowing anybody in the world to rewrite your Gmail cookies or extract them. So if maybe in a completely stateless, isolated HTTP context, somehow it's safe, but it definitely, I think, would constitute a violation of the HTTP semantic rules, because HTTPS URLs are only valid for authorities that have proven cryptographic control of that have cryptographic proof of control of the authority name. I don't see, as a standards matter, I don't see a problem with saying that the authority is an IP address that is totally different from the transport level IP address.
Okay. I think we'd probably want to comment on that to explicitly note, like, hey, by the way, it's fine to do that.
By the way, another interesting problem that this generates is that it requires, at least potentially requires the servers to use real names in their target names.
Yes. Yeah, that would be a consequence of this. Which, if we wanted it, I think would be okay. But yeah, that's fine. All right, Eric.
After checking to make sure it's actually the correct Eric, this whole area is one where I still have a lot of anxiety, but don't necessarily quite have the right answer here. I think the issues that the attacks people have just raised added on to some of the ones. I think even the topic of what to do with SNI is critical here, because a lot of these things are sufficiently multi-hosting environments that we need to make sure that the client must send a SNI that matches what it expects to come back. But there's the messy situation that the draft or the specifications for SNI only allow names to get sent. It doesn't allow IPv4 or v6 addresses to be encoded.
Right. So it is not possible to have any SNI for these.
Right. And I think but I think we need to have an SNI here because some of these are multi-tenant enough. Like you take the Google front end, if you just send it if you send to dns.google a request, you're not going to get back a cert that contains IP addresses because those are sufficiently multi-tenant that the server is not going to know what to reply. And that applies to a lot of other similar services. And what we want to avoid, especially on the v4 side, is people having to have different IP addresses just to demux against certs again, because that doesn't scale well. So,
although I think that is a consequence of using addresses here, right? And I mean, Ben can confirm, but I think these Google DNS resolvers, these do allow access without SNI.
But there's kind of this area, once we start looking at this, there's a bunch of things that start from I think there's a starting point of taking a step back on what is the security properties we're trying to get to. But then from there, at the other end, there's a practical deployment considerations. We should look at, even at least for some of the examples we're using, as to whether or not those would actually work in production, and whether or not those are going to be, whether or not they're going to be new vulnerabilities like the ones that were suggested that show up, kind of given these default configurations of how a number of things providing those services today work.
Just jumping in, make everyone aware of the time. We'll have about another, let's say, about 8 minutes of chat on this topic left. So probably even extend it maybe to 12. So I think you got a couple more in the queue.
Yep, Watson.
I think this proposal is the best we can do, and that makes me very unhappy because we're taking this IP address, you have this name flying around that you then resolve and you don't actually use for anything. And then with SNI, you're sort of going to have to send it to the same IPs that name resolves to, set them all up to work statically. There's just no way around that. And this whole thing makes me feel very sad that we can't use domain names freely everywhere and have to stick with IPs. I don't see a way around it because what you're looking for is an alternate way to reach something you only know by an IP address. And so you're only got an IP address as your root, as the thing you want to connect to.
Mm-hmm. All right, Tony.
So you can hear me, I take it. So
yep.
In the earlier discussions, it seemed to me like an alternative approach would be to document the security considerations and don't let servers branch behavior based on name provided, because it's not the authenticated portion of DDR. I don't know if that's still amenable to people, because like Tommy said, this isn't about requiring that name be used. It's not forbidding name to be used, where IP address can also be used. Because Ben has a point, making an HTTPS connection where we're not authenticating the host name is very odd. DDR itself doesn't require it, because the identity that DDR is authenticating is the starting IP address. In practice, I think there'll be two different things going on. We're confirming that the DDR recommendation was solid, but we're doing that over an HTTPS connection. And I want whoever gave me the DDR delegation to tell me, the designation to tell me the name that I should be using, because I'm not going to have my HTTPS stack not authenticate the host name. And if the name they provide is an IP address, that's fine. But if they want to provide a name like dns.google instead, that's fine too. But I totally acknowledge that that name can be modified by an attacker on the path back. And so not branching on that behavior is wise. So I'd be fair adding that security consideration, but I don't see that as a reason to forbid providing a name that includes alpha characters outside of just IP addresses in that target name.
Yeah, but that then does put requirements on any resolver that supports this. Yeah. Okay, Ben.
All right, so responding to Tommy first, I think there's a slight miscommunication there. So the example record that Tommy Polly has at the top of the slide would be considered valid and acceptable as a DDR record regardless. Nobody's demanding a change to the contents of the target name field here. It's just a question of what the client is allowed to do with that information. As for servers not branching on the authority, I think to summarize Ecker's point, that is currently a very common, generally allowed behavior. And so declaring that servers are not allowed to do it in the DDR context would be a pretty remarkable deviation from the rest of HTTP, where they are always allowed to branch on that. I wanted to quickly say, I think the ideal solution here might well be to enable essentially IP addresses in SNI. But that's not a topic for the ADD working group. But I think it might be sort of the cleanest solution here.
For cases like Google, like Quad 8, I mean, these, like, you do not need SNI for those to work, correct? In any of these addresses here.
So in the current configuration, my understanding is that yeah, if you send a TLS connection, if you open a TLS connection to 8888 port 443 with no SNI, you'll get a certificate back that includes the coverage of all the relevant IP addresses.
Yep.
And that's not the same certificate that you'll get if you try to open that connection to www.google.com.
Yeah, exactly.
So it depends on the host configuration. If you want more flexible virtual hosting, then I think currently we just don't have the ability to do that securely. And also, just to briefly to the point about DOPATH being attacker controlled, this is discussed in the security considerations of the SVCB for DNS draft, and I would welcome improvements to those security considerations.
And just to step in here from the chair, I think we're going to close the queue after Ecker.
Too.
I see the RFC 8738, the ACME IP identifier validation extension does allow IP addresses in SNA hostname, but with a suffix of IP with the ARPA to create a domain name with the IP address. So it does allow SNA hostname extension. So that should work for this specification, and we should be able to take host names within the SNA host field.
Okay, that's interesting. It'd be good to understand if that is widely
I'll
supported.
paste the example given in the spec in the chat, so
okay.
It makes it much easier.
All right. Okay.
Right, just waiting. Yeah, I think these are a number of issues here, probably, which I feel like we're gonna need someone to lay all this stuff down. There's the issue of like what has to be in the certificate. There's the issue of what the client has to send to induce it to be in the certificate, which is to say, like, supposing like are there servers, which I'm sure there are, which have IP certificates, but like don't use them if you don't send SNI or something. I don't know, or maybe there aren't any. But like what do we have to require?
They may just not be able to use this right now.
Yeah, exactly. It's a matter of saying like this is what you have to do if you're one of these things, right?
Yeah.
And then there's this question of what goes in host, right? So I think like those are all like kind of separable here. I guess one thing I would say is at the current moment, it's not sensible if someone sends you TLS client hello and no SNI, not to send them an IP address certificate if you have one. But if we had to, we could certainly certainly find some way to stuff SNI in
the address in SNI.
Here's an SNI. I don't think that ARPA thing is a good idea, but I'm sure you can find some way to do it. Another thing we could do is, by the way, just have a TLS flag that says, I didn't send you SNI, but I meant IP address, right? Because we now have flags for this purpose. So I think that problem is eminently soluble.
I would suggest that that's solvable outside of the scope of this.
I agree. We should like call TLS and ask them to do something.
Yep.
All right, I'm done. Thank you.
Okay, cool. So that's essentially it. It sounds like I'll modify the PR to just say, hey, you use the IP address. I think it'll just simplify the text, and I can share a link to that on the list. I believe after that, then we should be ready for working group last call.
Okay. Well, thank you, Tommy. And thanks everybody for great discussion there. So next up on the agenda, we have a quick update from the, I think Dan is going to do it, about DNR.
Yeah.
The slides are uploaded, Dan, so I just want to wrap presentation and put them up.
And that's clicking on meeting materials at the top?
It's, if you see, I have a thing that says share slides underneath my name, left-hand side.
Maybe you can show them real quick, because so we can just, oh, there we go.
The button, ask.
Cool.
They're up.
Yeah, they don't advance for me. So I only have one thing. Authors, consider this ready for a working group last call. I know we were holding off on doing that to do DDR and DNR at the same time to make sure that some of the security aspects of both are aligned, and we have no changes to the doc. But we consider this ready to go. That's my update.
Okay. Thanks, Dan. Any quick questions on DNR? Well, I'm getting a lot of echo. Okay, nobody's in the queue. Thanks, Dan.
Yep.
And Taylor isn't on, but we'll talk as well to see if we're going to continue on with the plan. I still like the plan of doing the two together so that they're in sync. So I think we'll probably hold off working group last call on DNR until DDR is updated with the current discussion that's going on. Okay, next up on the agenda, we have, who is going to, hang on, my agenda slides went away. We have Ben Schwartz, discovery of designated resolvers and presence of legacy forwarders. That's a heck of a title. Oh, re-request, Ben, I'll give it back. I'll give you approval. And then you have 10 minutes to present and 5 minutes for Q&A.
Okay, here we go. This is a draft by myself and Chris Box, inspired by a lot of discussion by a lot of different people in this working group who've thought about this topic. As a refresher, the topic in question is what to do when the client is speaking to a DNS forwarder identified by a local IP address, and the forwarder is just forwarding all the queries to a recursive resolver that actually supports an encrypted DNS protocol. And so the question is, can the client upgrade to use DNS over TLS to this recursive resolver? This is an opportunistic encryption situation. So the only identity the client knows for the DNS server is a local IP address, which is not a usable validation identity. So in this context, in DDR, when you're trying to upgrade, starting with insecure DNS, an active adversary can always win. An active adversary between the client and their sort of closest apparent resolver can always just drop the DDR queries and prevent DDR from ever happening, keep the client unencrypted, and monitor and modify their requests. So there's no real authenticated encryption. There's no real strong security possible here. We're only talking about shades of opportunistic encryption. So in this context, DDR says that the client is allowed to upgrade as long as the IP address of the encrypted resolver does not differ from the IP address of the unencrypted resolver. So they're continuing to send their traffic along the same network path, they're just encrypting it. And that works so long as the forwarder is, in a forwarder context, that works if the forwarder has been upgraded to fully implement DDR itself. But otherwise, it basically excludes upgrade across a forwarder. And we have a bunch of reports and sort of experience in the working group that says that there are a very large fraction of internet users who are essentially stuck behind one of these forwarders, where otherwise they would be able to use encrypted DNS to the upstream resolver. So this draft is an informational draft. We're discussing client policy, which the working group has, it's at least a challenge to say normative, to make normative statements about. So this draft doesn't attempt to make any normative statements about it. It considers a client policy that would have this, that would be able to upgrade in this context. And the key thing that changes with this client policy is that we remove this requirement that the IP address appear in the certificate if the unencrypted resolver is identified by one of these network local IP addresses, which we know cannot appear in a certificate. So the draft then discusses all of the issues that we thought of that this raises, and there are a lot of serious issues that are raised by a client policy like this, and also discusses a bunch of mitigations that can at least reduce the severity, and in some cases, maybe really fully compensate for these concerns. So first, I want to emphasize things that don't change that aren't affected by this discussion. Malware and threat domain filtering services are not affected here because they can very easily just add resolver.arpa to the list of domains that they don't allow access to that list has to be dynamically modifiable because they're chasing an evolving threat landscape or an evolving set of services that fall into their categories. So it's really straightforward for them to actually maintain control and prevent the cross forward or upgrade here if they want to prevent it. And also there are a lot of other things that are people like upstream resolvers doing things on behalf of the client. That's obviously not effective because we're not changing which upstream resolver is in use. But there are some real concerns with this. Clarifying questions, please. Neil?
Yeah, hi. I just wondered on the previous one, the time of use restrictions, what do you actually mean by that? Do you mean like how long someone's been using a service or just when someone's allowed to use a service?
Both of those things. I was thinking, in my mind, I was thinking about things like captive portal networks where users pay for a time-limited access, or family controls, parental controls that limit certain devices to no use after bedtime.
Okay, those kind of things do get implemented by DNS. Certainly the latter one, like no use after bedtime, that kind of stuff.
So I would definitely be interested in learning more about the implementation examples there. As we pointed out in the draft, it seems like it can't be implemented in any effective way using DNS because clients have substantial amounts of caching. So major services, like if you're accessing, I don't know, YouTube or something, there's a good chance that it's just going to continue to work after the DNS stops.
Oh shit, I'm not saying it works perfectly. I'm just saying it does. These do happen, and TTLs tend to be very low these days. So if you're browsing it, I'm sure there's some services once you've got the IP address, particularly video streaming, those are going to continue to work. But I'm just saying they do work. But I guess that I would put them in the same category as malware and threat domain filtering at that point anyway, because if they're being done by DNS, then the answer is the same, which is just to add resolver to upper to the list.
Okay, that's great. If you happen to have an example of a system that is implemented that way, that would definitely be interesting. But
yeah,
regardless, we can update the text.
I can send you
Thank you.
some examples.
Can we hold the rest of the queue and let Ben get through the rest of the slides? I think you're almost done, Ben, right? Slide-wise?
Yeah. Okay. So this does raise some concerns. One of the concerns here is that if somebody injected a long-lived DDR response, it appeared on the network for a few minutes, injected a long-lived DDR response that redirects everybody to their server, and then walks away, their attack can continue after they cease to be present. And so there are some potential that's a real concern, and there are some mitigations that can reduce the severity of that concern. One way to mitigate it would be to limit how long you cache these records, essentially cap the TTL. Another possible mitigation would be to essentially only accept an upgrade, an unauthenticated upgrade in this case, to a target that you have some reputation signal for, where you believe that they're not likely to be part of an attack. Another class of security concerns is related to how this interacts with forensic logging. And so the draft has some advice on how to configure forensic logging to make sure that you can still capture any attacks that might happen. And there are also some interesting compatibility impacts that could arise if a client tried to do this. So split horizon namespaces are a little bit like the threat domain filtering that we talked about earlier, but they're not necessarily dynamic. A forwarder could have been configured with a split horizon namespace 10 years ago and never touched since. We want to make sure that we don't break those configurations. And so there are ways to solve this, or at least there are applications that can avoid visible break in situations like this. And one mitigation we mentioned in the draft is NX domain fallback. So you can try to look up the domain through the upstream resolver, but if it fails, you can disable encrypted DNS and try again through the network's unencrypted resolver. That bears quite a bit of resemblance to behaviors that exist today in both Chrome and Firefox. There's some interesting questions around safe search type domains, which we coined the term interposable domains for these domains that are deliberately meant to be modified by resolvers in particular ways. Again, that might have been done 10 years ago once, and we don't want to break those configurations with any client-side changes. That would be a problem. So there's some discussion of what to do about that. The best mitigation that I thought of was just to basically keep track of the very small number of these weird things that are out there and avoid breaking them. And so this draft, it documents a secure, at least an alternative client policy that is in some sense no less secure than DDR itself, or at least secure under similar threat modeling. It documents the advantages and disadvantages that that client policy would carry, and it discusses some ways to mitigate the known problems. It doesn't have any recommendations on what you should do, and it's seeking working group adoption. One thing that I guess I just skipped reading the slide is that this alternative client policy, while it carries a bunch of tricky trade-offs, would likely enable a lot more DDR upgrades. So it would be likely to result in a large increase in the amount of encrypted DNS on the internet. Thanks. Let's open for questions. Vinny?
Example, and I think Chris verified this in chat, that the blocking really only applies to being done at the forwarder, because you never know if that request is actually making it to a cloud-based malware inspection service, right? It could be man in the middle before then. So yeah, this comment here, I think, only applies if the forwarder itself is providing that service, right?
I'm not sure what you're referring to, but in general, if threat filtering is implemented at the resolver, then it can continue to do that just by adding resolver.arpa to its list. And if threat filtering is implemented upstream of the forwarder, then that also won't be affected because users will continue to reach the same upstream resolver. Does that help?
But not in the case of an on-path attacker, right? Like if there's something between the forwarder and the upstream. Sorry, go ahead.
So we're talking here about legacy forwarders, which means they're not, in the context of this draft, means that they're in general not modifying queries on either leg. So an on-path attacker on either section of the path can always prevent the DDR upgrade just by dropping the DDR query or response.
Right, but the client doesn't know that there's a forwarder between it and the final destination, right? And the proposal here is to soften the security requirements of essentially the client to support this. Or did I misunderstand?
Yes, that's right. So this does impact other uses of DDR. It impacts the client security generally, and the draft walks through the implications of that. But it only applies when the apparent resolver is identified by a local IP address, which means that authenticated security is not really possible anyway. Barbara?
Thanks again for doing this draft, Ben. I think it's important. I would like to see this worked further. I don't know if it's something that would ever make it out of the last call, but I definitely would like to see it continue getting discussed, and so I would like to see it be adopted. I know that's one of the questions you have. Of course, we have been discussing about some of the IPv6 issues and things like that, and yeah, I just think these need to continue to be discussed, and this gives me some hope that we might find some sort of way that devices behind forwarders could get upgraded. Thanks.
I think Kira's next in queue.
Hey, Ben, I think this is a good start with regard to the millions of legacy routers that are there, but I think it should. I think we need lot more details to be discussed in the security consideration, especially with these legacy routers where even the config cannot be updated, and that's the case this draft is addressing. And even if the config cannot be updated, then it seems like with these home routers, they're easily susceptible to several firmware vulnerabilities, and typically they have several firmware upgrades to address those vulnerabilities. If those vulnerabilities are not getting fixed, then to support that kind of a deployment, right? I mean, is it like we're going to do this till 2025 and then stop supporting this model? Where is the end game for this, right? I understand it's a starting point because we have to transition to better routers, but are we going to do this for some duration and then stop supporting this as a stopgap?
That's an interesting question. The draft does not propose particularly a need to sunset this kind of behavior. Again, no normative recommendation client policy, but I think it's conceivable that the need for this could fall over time. I don't know.
Thanks, Ben.
And I'll close the queue after Andrew.
Yeah, so Ben, thanks for doing this. This has got a bunch of interesting sort of implications, but I suspect that people are going to be doing this exact behavior, and it will serve a very large number of people and provide them with some amount of encryption. I don't know how good it is, because obviously this is vulnerable to on-path attackers. And as Chira points out, one of those on-path attackers is the unpatched router that hasn't been updated to support this stuff. But it's certainly not worse than it was before in any way. And so I'd like to see us work on this. I don't think we need to set the bar particularly high when it comes to making sure that everything across the board is covered in the security considerations, particularly because that increases their exposure to the sorts of things that Barbara mentioned. I'd be interested in why Barbara thinks that this might not get through a last call. I realize that these sorts of things are always a little bit interesting, but I'd be interested in what those exact reasons were.
Thanks, Martin. Ray?
Right.
Yeah, hi. Thanks, Ben. A couple of things I noticed both with this draft and the previous discussed draft, the DNR draft. I think they could both do with, or both sets of authors could do looking at my RFC 5625, which is specifically about the class of DNS proxies found in home gateways. Specifically, I think for your draft, one of the biggest issues may be that actually most of these proxies or forwarders are not true forwarders in the DNS sense at all, but are actually just simple UDP ALGs, application layer gateways. They actually don't really speak the DNS protocol at all. They just forward it over UDP up to an upstream device and send the responses back. The other comment, which is probably more relevant to the DNR draft, I'm afraid I missed that section of the meeting, was that a lot of the time the upstream device does not know what the upstream DNS is going to be at the same time, or in readiness for the client to connect. Like, clients are online all the time, or so long as they've got power. But if the PPP session drops, which is quite common over DSL type home gateways, there simply is no upstream DHCP information to be had. So that's probably more for the DNR draft than for this one, but I would very strongly recommend both authors have a look at that previous RFC, and do get back to me, please, if you want any further details on that research I did.
Thank you. Andrew?
Hi, yeah. Two things. Firstly, a few people on the list have been commented about, or this will time out as CPE is replaced, which is probably true. But I would politely suggest that maybe some people are completely overestimating how quickly the vast majority of the market replaces its CPE. Those of us familiar with ISPs will know that consumer customers, you're lucky to get them to change in a 10-year time frame. That's not because the ISP doesn't want to change, that's because the consumers have got a lot of inertia. You can send them free stuff and they won't necessarily unwrap it, let alone switch it on. So this isn't a problem that's just going to disappear in 12 months. Most people don't have the budgeting of a tech firm. And I think we need to consider that. This is a long-term hardware problem, not a software problem. And the other thing which we shouldn't overlook either, let's remind ourselves this is 85% of the market. This is a non-trivial thing. If we don't do this or something like this, then we're really just doing a corner case. So I think this is tremendously important that we come up to a solution here. Thanks.
Thank you, Andrew. One thing I'll quickly say is that there might even be cases in the indefinite future for this. If you imagine a forwarder that really wants to get out of the way, is trying to get out of the way, it might actually want clients to do this kind of cross-forwarder upgrade. But we can talk about that later. Back to you, Glenn.
Okay, thank you, Ben. By the way, I'll comment. I think this is having these smaller drafts that we can focus on issues around this. This is a great way to work through and resolve them. So thanks to both you and Chris for putting this one together and letting us talk through this, because we've been touching this issue for quite a while now. So it's good to see us making progress on it. So thank you. Next up, we have we've had this discussion around a couple of drafts that we have issued a working group adoption around. And we had low feedback on the list. And so the chairs have been trying to work through the right, I'm getting a lot of echo, 1 second. Dan, could you mute your stuff? Okay, thank you. And so the chairs have been trying to work through what the right path here, and we're looking for direction from the group, because ultimately it's the working group that decides what gets adopted and what we work on. So the first one we're going to do here is we're going to talk about the split horizon DNS configuration, and let's keep the topic focused around there. What we're really looking for here is not to turn this session into like a debate on do we adopt or do we not adopt, but let's talk about the document and is this something that the group feels that we should be ultimately adopting or not, what were your feelings on that? And then ultimately we're going to we have the request for adoption out on the list still, and ultimately we're looking for feedback here and there, and then we'll try to figure out if we move forward with one or both or either of these drafts. Okay, with that said, who's going to talk to the split horizon DNS config? Is that Dan?
That's Dan.
Okay. Do you want me to run the slide again, or do you want to take it and do it on your end?
Yeah, let's do that. I was going to switch computers to try to resolve the audio, but I didn't get the other system set up, so
okay,
avoid me also trying to figure out the slides. Sorry. There's only 3 or 4 of them.
Okay.
Thanks.
Trouble getting that particular slide. I imported them. Give me 1 second here. My apologies for the.
It's not liking things.
Yeah, no, hang on.
It takes a while. Leave it for a second. Meet Echo takes a good 15 seconds before slides appear.
No, it's that I added them to the queue of things to present, but it seems to have disappeared out of the queue, or I can't scroll anymore. So, give me a second here. I'm doing really badly here.
Yeah, perhaps the PDF renderer is confused with the PDF.
No, the problem is that there's a list of documents which have been imported to the session, and I imported all of the ones ahead of this, and now it's not showing up in there, this particular document.
Okay.
And I don't remember how I imported it, to be honest. Let me try it this way. Okay, we're going to try it the old-fashioned way. And I'm running into problems. And all right, can you see the slides?
Yes.
Okay. We're going old school.
So,
all right.
Maybe the echo will be better too.
Let me know when. Okay. Yeah.
Yep. Go to slide 2. So the last time we presented this was last IETF. It was version 4. We're now at version 7. Removed a little bit of latent text that was accidentally in there talking about the enterprise use cases. So this is and has been intended for a couple of versions now to cover non-enterprise use cases, specifically for mobile ISPs wanting their subscribers to be able to get to certain resources and pay their bill and whatever. And thanks to a comment from Paul, we added better support for handling geographic subdomains for split horizon, where there's a country name or a city name or something in the DNS server name, which is pretty common. And then Glenn wanted an example message flow, so that's on the next slide. So we added text in the document and in the next slide, and ASCII art, beautiful ASCII art, into the document as well. So next slide, please, Glenn. So this shows what we're doing. The green stuff at the bottom is what's new. The rest of it is exercise existing specifications. So steps 1 through 7 are exercise existing specifications. Then what we're proposing in the document to do differently is, after gathering the information from steps 1 through 7, which is what are the local DNR host names, what are their IP addresses, and what's the FQDN for the provisioning domain, and learning the details of the provisioning domain and getting that JSON back. After getting all that stuff in steps 1 through 7, is go off and talk to a public resolver and ask it who owns that domain, and see that there's a match. If there is a match, then continue using that network encrypted resolver that claimed to be authoritative for that domain and claimed to be responsible for it, and use it for that domain. And that's the gist of what we're proposing. And that's really my update. I have another slide. We may want to just flip back and forth between this one and the last one to help frame the discussion. But the last slide that I have is, does this describe a real problem? Do we want to have strong authentication and authorization of split horizon DNS? And is this mechanism reasonable? And I think there are two separate questions. This is just the mechanism we thought was reasonable. And go. Paul, you're first.
And let me make one comment from the chair view, is I believe that we're going to if we do adopt it, it will get renamed. So if people are upset with the word enterprise in there, I think there was general agreement that the word enterprise would get removed in a renamed adopted version.
Agreed.
So, okay, let's go to the queue.
Hi there. Okay, Paul speaking. So I'm still a little confused about the relationship of the the split DNS that is not in the public view and sort of asking the public view for confirmation that this non-global space exists. Because if you're asking a public server if it exists and you get a confirmation it exists, then it's not a private space anymore. So then why is anything needed at all? Especially if you're not talking about an enterprise split, but about like some custom portaling page, then didn't they just put it in public DNS? So then why do you need this split?
So a lot of enterprises enjoy doing this split so that they only have their public servers on the public DNS, as we know, and they have all of their thousands and thousands of private domains on their split horizon DNS that are only accessible internally. And that's how lots of enterprises have enjoyed deploying their DNS, you know,
Okay, so then you're talking about the enterprise split DNS, and so then I agree that there's lots of domains internal only, but then I don't understand how you can ask a public server on the internet about these domains that only exist internally.
So there's two possible answers when we ask the public DNS about a domain. One is it doesn't exist, in which case, yes, it's internal only and only exists internally. It's some fictitious name like Cortana for Microsoft, for example, that doesn't exist on the public DNS. Or it's a split domain where it does exist in the public DNS and the answers that come back on the public are different than the answers that come back on the internal, on the private. In which case, that's where we're trying to find this match that we have described, and that is a split DNS.
So I guess then I'm worried about things like ISPs doing typo squatting on other domains that are similar to things they don't control or something. But I guess I still don't fully understand the use case and the authentication. But I'll take my stuff further to the list.
So, okay. So this is intended to detect that someone is trying to typo squat and prevent that from happening, and have this cause a failure, that the local network that is claiming to own, let's say, apple.com, and it's Starbucks, you know, and something weird is going on purpose at the Starbucks, we can prove that it does not own apple.com, and it should not have the split DNS queries sent to the local Starbucks name server that someone is advertising there with, you know, their SSID and their Raspberry Pi sitting in the corner or whatever, is to detect that very case and prevent that from happening.
So one comment on that, Dan, maybe that might be something that could be added as some additional security description text within the draft.
Okay, agreed, it's not in there.
Okay, Watson?
Hi, Watson Ladd, Clever. I am very confused by at first, I don't think split DNS is a good idea. You don't need it. It conflates name visibility and being able to access servers, and that's not how the internet works. And then with this draft, I have the same confusion as Paul. If you have a namespace that's public, and you're just trying to get your resolver to come back with an answer, you know, by using a public resolver for this, why can't you tell your client to go to a resolver and set up the DNS already? And this authentication thing is just sort of odd. So I'm not sure. You know, I think there's a lot of problems with a mechanism that's saying, okay, we're going to hand out different answers through public resolvers, or notice that our name servers are. We get back from a public. You don't get the name server from a public recursive resolver. You get the answer back. So if you're going to do the crawling of DNS yourself, you don't really have a problem. Or maybe I'm just misunderstanding this entirely.
Okay, so you're saying there isn't a real problem to solve, and I believe is what you're saying.
No, I'm saying if what you're doing if the problem is that you're using a public recursor, you're not going to get split DNS that way. If you're using a private recursor, you don't have a problem. Private recursor is talking to authoritative that give it the split view.
Okay.
Tommy?
All right. And I think this is definitely a real problem, for better or worse. You know, I care a lot about how we handle split DNS. Paul and I wrote a document for how to do it in IPv2. So I think it's, I think the answer to the first one is yes, there is a real problem here. I'm not quite sure about the solution, and I think more importantly for the question of adoption, and this is what I brought up on the list, I'm wondering still where this belongs. It seems like this is a bigger thing to tackle than just what we're doing in ADD. ADD is how we're doing discovery of resolvers. This is going into a much bigger question about how a network expresses authority over specific resources, which is really interesting, but that could have its own working group to talk about all the details there. You know, I like the idea of using PVDs somewhere in this. PVDs was done in int area, and we need some of that audience to do the work, not just what we have in ADD.
Okay.
And then just to the solution a little bit, I think the case where you have you know, a purely private name or a private domain, which I think this tries to address, I don't see that as too much of a hard scenario. So, you know, we're already using encrypted DNS for our iCloud Private Relay service with Apple. And we fail over for non-public names. If you try to get to some resource on the internal mobile network that doesn't resolve, we try it publicly and then we try it locally. And by policy that can work. There are easy ways to have clients work around that. The biggest problem I have seen, and it keeps coming back up again and again, that things like IPv2 split DNS could fix, is how you handle dual facing servers that have dual resolving, right? Like I have a name which is public, and when I'm at the cafe, I want it to resolve one way, but then I'm on my internal network and it resolves to the internal version of the web page. And I hate that that exists, but it does exist, and that is the hardest problem. So I think that's the type of thing we need to solve in this space, and I think it's harder than what we have so far here. So I want to see the work continue, but we need more work.
Okay.
So then, Tommy, let me clarify what your point is. You're sort of saying that it's an important problem, do the work, but don't do it in ADD, do it in a bigger context.
We need to bring in and instead of saying this is how you do DNS within ADD, we need to kind of turn the problem on its head and like, how do we do this type of discovery of authority on a network?
Okay. Thanks. Ben?
Hi. Okay, I'm broadly supportive of this draft. I view it as a harm reduction sort of case. I really don't like split DNS, and I would prefer to just get rid of it. But if we accept that we're not going to get rid of split DNS, then I think we need to provide better guidance about how it is that you prove to the members of your network that they're actually getting valid answers, and that they're going to get valid answers, that they need to, that it's secure and appropriate for them to be connecting to particular servers to get answers for particular names. And I think this draft actually achieves that. So I think it's worth moving forward with for that reason. I do think that there are two, as you pointed out, there are two separate solutions here. And essentially for these two cases, one of which, for names that truly do not exist in the public DNS, really that means non-existent TLDs, because otherwise the draft effectively requires you to prove the, well, and I guess I should reread it again and see. But there are fundamentally two cases, one of which is the name exists in the public DNS, and one of which is the name doesn't exist. So if you're talking about cases where the name does not exist in the public DNS, that's the case where NX domain fallback, as Tommy Pauly mentioned, already handles quite well. It's also the case that creates the risk of typo squatting that Paul Wouters pointed out. I think it would be worth considering removing that from this draft and focusing on the hard case, the case where the name potentially does exist in the public DNS, but you still want users to resolve it differently on your network. I think that the discussion of use of public resolvers, while it's very practical, I think is raising a lot of hairs on people's necks and is not actually necessary. I think it would be clearer if the draft based that entirely in DNSSEC, and that the draft can be done without any discussion of public resolvers, if you, or at least without any reliance on them, if you say that the authentication of the relationship between the covered name and the local resolver is based in DNSSEC. And then, if people want to delegate DNSSEC validation to a trusted third party, that's their business. We don't have to tell them to do that. So overall, I'm supportive, but I think the draft needs a lot of work and may not be ready for adoption. But that doesn't mean it's not worthwhile. Thanks.
Cool. Thanks for your comments.
Ecker?
Yeah. I also don't. So I think this is. I guess we take this in order. I think this is an interesting problem, which I wish was not a problem. But like probably one we do have to attack in some way, or at least like make a run at. By we, I mean IETF collectively. I don't think the draft also is quite ready for adoption. I think I have a better understanding what the solution was like. I think there's like enough question that we can actually solve the problem that I have a solution that I was pretty confident of in hand. I'm agnostic on the question of whether it goes in ADD or in some other group. I would let the ADs worry about that. This seems like a situation where people float around a little bit. I agree with Ben that the non-existence case is less interesting than the multiple answers case. We also fall back. That seems like the kind of solution people are gonna. I mean, that's the thing you're gonna have to do anyway. I mean, because of the deployment realities, this will not be universally deployed, and therefore there'll be a lot of places with split horizon where you have to fall back anyway. And so, really, doesn't help you that much to have to have this out there just for the non-existence case. And finally, I think unusually off-brand for me. I think DNSSEC is the right answer for this for this case. And I would observe that, in fact, if you have DNSSEC, you could probably substantially simplify this structure in the sense that you don't need to do this query the public resolver thing because you can just stuff the DNSSEC delegation right into the PVD. So I think if people want to do something which honestly kind of stinks, at least they can do is DNSSEC side their linkage.
Okay, thanks.
Andrew?
Just commenting a few comments in the chat, sort of saying that this shouldn't be done because it's a bad thing to do, which may or may not be true. But on the other hand, it's what people are doing. So given that we have to deal with the as is rather than what we'd like it to be, then I think we absolutely need a solution for split horizon. It's a common practice in enterprises and other use cases as the draft sort of details, and therefore I fail to see why we shouldn't adopt it. And I think it's a problem we need to solve because it directly affects the use of encrypted DNS, which otherwise bypasses split horizon solutions. So I think we need to own the problem here rather than elsewhere. But clearly other people think differently, but there you are. I think let's adopt it.
Thank you, Andrew. Vinny?
Thanks.
Yeah, thanks. So Tommy, back to the comment you made earlier, and I put this in chat. The problem with NX domain in terms of enterprises is you're leaking enterprise private names to public DNS servers. And we put a lot of work over the last 15 years into VPN clients to actually block that behavior because customers have demanded that, right? They don't want their private DNS names resolved by, or attempted to be resolved by, resolvers other than their own. So I think, you know, that problem needs to be solved in a way that, and I think beyond just VPN, in a way generically for DNS, right? Additionally, we've put a lot of effort into, you know, zero round trip time protocol improvements, and NX domain processing, you know, adds latency for every request that's to failed and tried again on a different interface. Now there is some parallel DNS, opportunistic DNS resolutions, but again, those start sending enterprise DNS names out over interfaces that the enterprise doesn't want them sent over. So I think there's value in this proposal. It still needs some work to improve on that, but I do think there's value here.
Thank you, Vinny. Eric, are you wearing your AD hat, or are you just Eric?
And if we see this one, let's discuss in the chat, not if we care, but whatever. So I hear a lot of interest in this draft. Also here there are some issues, but we are talking about for a call for adoption. So my only slight concern about the call for adoption is whether it should be done in AD&D or someplace else. My understanding is really it fits ADD charter. So for me, that's good. We may want to check with the chair, with DNS op and Interarea chairs as well, whether there's a best fit outside. But for me, it fits ADD. People at ADD are aware of the problem, so it should stay there. But I will double check. But again, it's just for a call for adoption, so there's normal to have issues. Let's solve those issues before the working group last call.
Thank you, Eric. And Wes.
Thanks. So this space has a huge amount of history in it, and though it may seem like ADD is an interesting first place to hit it, it's actually quite old. And I just sent a note to the mailing list that includes even a draft going back to 2007 for how to deal with split DNS within DNSSEC and how hard that is, as well as RFC 8244 should definitely be read, when considering this, because it talks about all the issues with private namespaces and how much trouble that's caused. And between both DNS within the IETF, including DNS op, and within ICANN, this problem, has a very ugly rearing head that is much larger than this group. So I'd tread cautiously, because if you think you're going to add a split DNS just in the context of ADD or how to deal with it just here, there'd be huge dragons there. So it's a really hard problem.
You stole my comment, Wes. I was gonna say, so in summary, there are dragons there.
Yep.
You beat me to it.
Yeah, that
Okay.
2007 DNSSEC split horizon draft was great. I have not dug into the history of why it was abandoned, but it describes 4 ways of deploying DNSSEC with split horizon. 3 of them would work with what we have in mind. 1 of them doesn't. And that would take on, that would eliminate, like several people suggested, it would eliminate having to talk to the public DNS to ask it any questions. Instead, you'd have all the answers in the DNS signed records yourself.
So I can answer the abandonment issue, because that was written by my coworker, and the working group couldn't come to agreement that it was a good thing to do.
I can feel that. Thanks.
Okay. Thank you, Dan. So please continue this discussion on list. As you can tell, Eric, our AD, is paying attention. The chairs are paying attention, and we're trying to really sort this through. And I've heard some good suggestions here, especially talking to the other potential groups. And so as the chair, we'll do that. We'll go have that conversation. But please continue the discussion on this one. All right, and then we have the other document, and let me bring that one up. And we can talk about that next one. Neil, give me 1 second, or can you bring up the? hang on. Let me try to bring the document up for you. So this is the deployment considerations document. Let me make sure I got the right one. It's the 5-page one. Okay, everyone can see?
Okay, this is old-fashioned. You do it for me.
Yeah, I'll do it for you. So you let me know when you want to change the page.
Okay. All right, change the page. All right, so I'm going to speak on behalf of my co-authors. So this is really the approach here is just very high-level architectures to capture like the deployment scenarios that cover the ad protocols, specifically really about in home networks when you're deploying ad protocols in home networks. It's not going into any kind of network specifics, all of that. It's really about the ad protocol that you need to do that. We really used this when we were kind of figuring out how to do DNR. We used it really to just describe all the different options for what DNR would do, what DDR would do, and just kind of go through the different scenarios. You go to the next slide. So this was actually part of the DNR spec originally. So we pulled it out. It wasn't really appropriate to be in the DNR spec, but as I said, we did use it as a really helpful guide for us to work out like what all those scenarios would be, what was appropriate to DNR, kind of figure out all the different possibilities, and what would be specific to DNR, what would be specific to DDR, and kind of figure out all the edge cases. So we pulled it down to a different spec because it was clearly not appropriate to have it just in the DNR spec. And so that's what this is. That's what this document is. We found it really helpful when we were creating DNR, although it's not really specific to DNR. Yeah, it hasn't changed since the last IETF meeting. So there's nothing new in the document. Next slide. What it mainly focuses on is the target deployment, so managed and unmanaged home router scenarios. And what do you do if you're hosting a forwarder in the local network? So when would you use DNR? When would you use DDR? Some options when you might use ACME, these kind of things. There's some nice network diagrams. When would you use? What would it look like when you have a legacy router that can't be upgraded? What would you do if you've got a legacy router that you can upgrade? All of that kind of stuff. So I think the target is for people so ISPs who might be looking at what they would do to upgrade their routers with encrypted DNS, or they would put forwarders on, proxies on them, for example, how they would do that. People who actually want to put forwarders and proxies on routers, you know, for myself, I work for Power DNS. We have DNSDIS, which works on OpenWRT now, for example, those kind of things. So I think that's really the target. But really, next slide. The question is this appropriate for ADD? Is this something that we should have as a working group document? I mean, at best, it's informational, but is this something we want to work on as a group? I don't think it's actually requires a great deal of work as a group. I know Ekas was saying this isn't, this is something that would have priority as a working group document. I don't think it would need a lot of priority as a group, but I'd just be interested if folks think it's useful for us to adopt as a group or not. And I think as an author, and I think I'm speaking on behalf of my co-authors, we're not like super. We're not going to stand here and like fight. We're not going to die on this particular hill. But I said we found it useful when we were developing it. So if people find it useful, great. If not, then also fine.
So before I open the queue up for people to make comments, one thought the chairs have had, and talking with Eric as well about this document, ADD in our charter does have a sort of an informational document listed as one of our deliverables. And this document as it stands isn't that document. But one thought is, if we create that, when we do create that other document, maybe this material is sort of like a subset of that bigger informational document. And maybe one path would be to, start work on that informational document, take out of this document the relevant and useful pieces, imported into that new draft. And that becomes sort of where this all ends up. It doesn't end up in the DNR draft. It doesn't end up in this draft potentially. It ends up in that broader informational document, which we do have in the charter. So that's one thought that we were thinking. Obviously, that's just from the chair's perspective. It's up to the group and it's up to authors if they would want to maybe take that path as well to move forward. But anyways, let's open the queue up and have people comment. Andrew.
Good reminder that it's actually something that we put in the charter. So I think that's important. Also, if I'm honest, just reflecting on the conversation that we've had over the last two papers in particular, that to me underlines the usefulness of actually documenting this, because there are clearly very different understandings of market requirements in different places. So writing it down in an informational document and just using that as a helpful reference would seem to me to serve a very helpful purpose, just so we're all clear what use cases we're covering. So I absolutely think this should be adopted as an informational document that we use. Thanks.
Eric?
Right. So I think first, this is not, as you say, this is not even remotely the thing that's in the charter. The charter is an information mechanism for describes mechanisms for clients to test specific network environments, which is actually much more like the presentation we just saw prior to this. So perhaps we could stuff some stuff from here into that document, but until someone starts that document, this is not like that. I think there's some valuable material in this document. But I also think that there's some material I do not agree with, and I suspect there's not agree with, and I do not want to spend the next 2 years of my life litigating every single piece of that, which is exactly what will happen if we adopt this and treat this as something that the working groups have to pay attention to. We have proposals for 2 actual things, and we should pick up or down on those proposals on their own merits. And this document, I think, is perfectly fine sitting as an internet draft, and people can continue to update it, and people can refer to it as they please, and people can move forward by it, but it does not need to be any kind of working group item.
I'm really interested that you say that there's a bunch of stuff in here that you don't agree with, because I'm astonished by that, because I thought it was completely uncontroversial, because it mainly just sort of sits there and lists a bunch of scenarios of how you can use ADD protocols. So, and I haven't seen anything from you on the list about your specific.
Yeah, I decided it was not where I decided I didn't want to engage in a bunch of details because my position was it should be adopted, and I could not pay attention to it. If we adopted it, I will give it a close read.
Okay.
I'm sorry. I wish I had an example for you. I just remember reading it and being kind of yeah, I don't agree with this, but whatever. So,
I certainly think one of the things that it could be done, it certainly reads as a bit prescriptive sometimes, which I think it certainly probably could do without. It shouldn't be prescriptive, but yeah.
Sure. Well, again, I'm sorry, I don't have a more clear example for you. I've been up since 3:30.
Okay. Thanks.
Okay. Next one will be Tommy.
Right. Yeah, I mean, largely I agree with what Ecker was saying. I think, yeah, I mean, the content here isn't bad, but it also doesn't feel like it's directly, deeply tied into ADD. And a lot of this may just be also the framing of how it reads. I would strongly suggest, since we have an informational document in the charter that needs to get done at some point, and we have a bunch of authors who want to write the informational text to help people understand how to do deployments, it seems like taking the suggestion to, start working on that document, figure out what of the stuff you have here makes sense in there or as an appendix in that document would be a really good use of our time and effort, so that we don't end up getting into conversations on this and having arguments about it, about how it should go, and instead just say, yeah, we need an informational document anyway. Let's make progress on that. We've already agreed to that in the charter.
Right. I personally, not speaking for my co-authors here, but I personally see the idea of it being part of a larger document perfectly reasonable. I don't quite get the point about it not being that relevant for ADD. It pretty much exclusively covers ADD scenarios. It certainly doesn't cover the whole of ADD. It covers a specific topic for ADD, which is deployment essentially of ADD in home networks where you've got CPEs. So it's a kind of a narrow subset of ADD, but it almost exclusively covers ADD. It covers the discovery of encrypted protocols in the situation where you've got CPEs in home networks, which is, by the way, I'm going to just remind everyone, the most common way that people around the world access the internet. So I think that often gets lost here. That is the most common way that people access the internet. So everything we're talking about here, if anyone thinks that those scenarios are not relevant to ADD, then please, tell me now, because that I think they are the most relevant ways that people access the internet today. So
I guess what I would say to that is, there's a lot of detail of diagrams here that before we even talk about how ADD works, it explains, here's how ISPs deploy their networks, et cetera, et cetera. That feels like, there could be some document in DNSOP that here's a catalog of different deployment types that something that ADD did as informational could reference to say, and here is the pretty simple way in which that gets expressed. But a group that's talking about discovery specifically, this is a catalog that seems to go beyond some of our expertise and should have a lot of input from generic DNS ops and operators.
Sure. I think the problem is if those things don't exist, sometimes you just have to kind of roll your own because you're trying to make something that makes sense as a standalone document and without something else to reference. But I take the point.
Okay, thank you, Tommy. Eric.
This draft is indeed relevant to AD&D, but it does not fit the charter as it is. So it really cannot be adopted as it is with the abstract and its content. I can only suggest, because the content seems interesting and useful, to aid in with to DNS op, or like already said, include it into the larger informational document deliverable, which is in the charter and the milestone of ADD. But like it is, I'm afraid it cannot go forward. It cannot be adopted. This issue can continue, obviously, as it's relevant to ADD.
Thank you, Eric. Any other comments from the floor, the group? Okay, well, thank you, Neil.
Okay.
And we'll continue discussion on this and among the chairs, and I guess the other to do there is for us to go have a conversation, at least on the chairs, to go have a conversation with maybe DNS ops as well. Okay. So that brings us to the end. I'm going to stop sharing that. So everyone, that's it. Thank you for your time participating today. And we'll give you back 12 minutes of your busy schedule. And I guess, thank you so much. Take care, everyone.